Welcome everyone to the lecture series on sensors and transducers. I am Professor Kiran Kumar N. Hittanigi, working as assistant professor in Department of Electrical and Electronics Engineering, KLS VDIT Hadiyar. So today we will be discussing module 4, lecture number 30. So in the previous lecture, we discussed about signal modulation. Okay, so we understood that signal modulation is required when we want to transmit the low frequency signal to a very long distance, right? So there are mainly three types of signal modulation. So out of three, we discussed frequency modulation and amplitude modulation types, right? Later, we also discussed briefly about the working of modem. So modem is nothing but it is a modulator and a demodulator. Okay, it functions as both modulator as and demodulator. So in today's lecture, we'll be discussing about introduction of pressure measurement. Okay, so later we will be discussing about different types of electrical pressure transducers. Okay, so from now onwards, from this lecture onwards, we'll be discussing about measurement of non-electrical quantities such as pressure, okay, uh, liquid level, okay, viscosity, uh, displacement, and uh, rotation in terms of RPM. Okay, so flow measurement. Okay, so these are some of the non-electrical quantities we are going to measure in the upcoming lectures. The learning outcome of this lecture will be, at the end of this class, student will be able to explain working of different types of electrical pressure transducers. Okay, right. So now we'll move on with the pressure measurement. Okay, so how we will define the pressure? Pressure is uh, pressure is force per unit area, you know, F divided by A. Okay, so pressures are generally exerted by gases, vapors, and liquids. Okay, the instruments that we generally use, however, record pressures as the difference between two pressures. So basically, the pressure measuring devices measure the pressure so in such a way that they will consider the difference between two pressure. So what are those two difference pressure? Means basically here pressure is measured keeping another pressure as a reference. So to understand that, we'll understand the next sentence. Thus, it is the difference between the pressure exerted by a fluid, okay, and the ambient atmospheric pressure. Means it clearly tells that, so the pressure of a liquid or the fluid I want to measure is measured with reference to ambient atmospheric pressure. Okay, so such devices indicate the pressure either above or below the atmospheric pressure. So in simple words, we are considering atmospheric pressure as the reference. Okay, keeping that as a reference, we are going to measure the pressure of a fluid or a gas or a vapor. Correct. And moving further, these pressure measuring transducers, or generally they are called as gauges. Correct. So they are popularly called as gauges. So gauge is another name for transducer. So we commonly find the pressure gauges in industries. Okay, for measuring the pressure. So one simple example we can quote is uh, in a steam boiler. We need to continuously monitor the pressure of the steam. So for that purpose, I need a pressure gauge. Correct. So generally, those pressure gauges will be mechanical type of pressure gauges. But here we will be mainly discussing about electrical type of pressure gauges or the pressure measuring transducers. Means here we are converting the pressure into its equivalent electrical signal, its proportional electrical signal, and later we are going to measure the value. Okay, so now we will define some of the terms, okay, which are commonly used in the pressure measurement. So first one is atmospheric pressure. So the atmospheric air exerts a normal pressure upon all surfaces with which it is in contact. So this is known as atmospheric pressure. Okay, this is basically a pressure. This is the pressure exerted by the atmospheric air. Okay, so this is taken as a reference for pressure measurement. The atmospheric pressure is also known as what? Barometric pressure. Okay, right. So next one is gauge pressure. So what is gauge pressure? So it is the pressure measured with the help of pressure measuring instrument in which atmospheric pressure is taken as datum. So here datum means it is a starting point of a scale. It is a starting point of a scale, or we can call it a origin or a baseline. Okay, so gauge in the gauge pressure measurement, what we do is we consider atmospheric pressure as the base value. Okay, so we are going to measure the gauge pressures above and below the atmospheric value. Correct. So next sentence will be gauges record the pressure above or below the local atmospheric pressure. So we need to understand that local atmospheric pressure. So it is a local atmospheric pressure. Hence, it keeps on. It it changes with the places. Okay. So region wise, it may vary. Okay. Place wise, it may vary. Okay. So that point we need to keep in mind. Okay. So atmospheric pressure will be varying depending upon the places. Correct. So that's why there is another pressure term comes into picture, that is absolute pressure. Okay, so in order to overcome this local atmospheric pressures, so variation in the atmospheric pressures, so the remedy is absolute pressure. Okay, it is necessary to establish an absolute pressure scale which is independent of the changes in atmospheric pressure. Correct? So a pressure of absolute zero can exist only in complete vacuum. Okay, so if you consider atmospheric pressure, it keeps on it keeps on changing with the places. Okay, but the pressure in the vacuum will be constant. Okay, so that can be taken as a absolute zero value. Okay, so if you consider that as a absolute zero value, and if you measure the pressure, it will be more accurate. Correct? So any pressure measured above the absolute zero of pressure is termed as absolute pressure. Okay, so absolute pressure is measured above the absolute zero scale. So absolute zero value, how we are going to get? So it is the pressure in the vacuum. Okay, so this is the diagram which will give us a relationship between different pressures. Okay, so here this one is a atmospheric pressure scale. So this is the atmospheric pressure line. Okay, so above, so this is the atmospheric pressure value. So here we have taken a scale. So above this atmospheric pressure and below this atmospheric pressure, we will measure the gauge pressures. Correct? So here you can see above atmospheric pressure line, it is a positive gauge pressure. Below atmospheric pressure line, it is negative gauge pressure. Okay, and now where is the absolute zero pressure line? So that is here. So absolute zero pressure line or pressure at the vacuum. So that is here. Okay, so above this line we are going to measure what? Absolute pressures. Okay, above this line we are going to measure absolute pressures. Okay, so this diagram will give us a clear picture of all the three pressure terms. Okay, atmospheric pressure, gauge pressure, and absolute pressure. So now we will discuss about electrical pressure transducers. So these are the transducers which will convert the pressure into its equivalent electrical signal. Later that electrical signal is processed and we are going to measure the pressure, right? So here we are mainly using a Bowden spring, or we call it as a Bowden tube, correct? So Bowden tube, what it will do, it will it will sense the pressure and it will convert that into a movement or a displacement, correct? So generally we have seen in the previous transducers, Bowden tube, what it does, so it senses the pressure and it proportionately moves the slider. Okay, it proportionately moves the slider. Okay, so what are the different types of pressure transducers? So we have resistance type pressure transducers, pressure voltage type transducer. Here pressure is converted into proportional voltage, so hence it is called as pressure voltage type. Inductive type, inductive type, inductive type, and we have capacitive type, carbon pile type, piezoelectric type, photoelectric type, and electromagnetic type. So in this lecture we will be dealing with resistance type, pressure type, and inductive type pressure transducers. Okay, so to begin with resistance type pressure transducers. Resistance type devices used in pressure transducers include strain gauges and moving contacts. Okay, one is a strain gauge type of transducer and another one is a moving contact type of transducer. So we already know the working of a strain gauge, correct? And we are very much familiar with its construction. So figure 2 shows the strain gauge type transducer. Okay, so this is the ceramic frame. Okay, so on which we have placed the resistive material, that is a grid wire we are calling, and these are the output terminals. Okay, so we'll see how it works. Okay, we'll go through it, the points. When the grid is distorted, okay, when the grid is distorted, the resistance of the wire changes. We know that. So we know this very basic equation. R is resistance of the wire, rho R is equal to rho L by A, where rho is the resistivity of the wire uh, material with which wire is made up of, and length of the wire, and A is the area. Okay, as the strain gauge is distorted by the elastic deformation element, its length is increased, cross-sectional area is reduced. So if length increase and area decreases, what happens? Resistance will increase, which will result in increase in the resistance. Okay, so we'll understand it even better. So when pressure is applied on the strain gauge, okay, due to elastic deformation, so this wire is going to undergo elastic deformation. So when this undergo elastic deformation, so it gets stretched. The wire gets stretched, which will lead to the increase in the length. So when it gets stretched, its area will decrease. So what happens as a result? Resistance will increase, correct? So that increase in resistance we are going to measure in the output terminals. Okay, so later resistance is converted into its equivalent voltage. Okay, so by the voltage value whatever we are getting, we can calibrate that value to its equivalent pressure. So by that, in that way, we can measure the pressure value. Correct. So basically here pressure is converted into its equivalent resistance. Okay. So next type is moving contact type resistance transducer. Okay. So figure 2b shows the moving contact type transducer. So here we have a moving contact. Okay. Here we have a moving contact which moves according to the change in the pressure. Okay. So here we have a bellow, so which will transfer the change in the pressure to this moving contact. Okay. So pressure is transferred to the moving contact with the help of this bellow. Okay. So here we have a resistive element. Okay. And this is the slider. This is a slider which moves according to the movement of moving contact. Okay. So if the moving contact moves down, slider will also move down. And similarly, so if it moves up, moving contact moves up, the slider will also move up. So when slider moves down, and here these are the output terminals where we are going to record the resistance. So if slider moves down, resistance decreases. If the slider moves up, resistance increases. Right. This type of transducer is most often used with bellows because of the force required. So pressure is converted into force. So pressure is converted into force, and that force is applied on the moving contact with the help of bellow. Correct. So when pressure is applied, the bellow moves the slider proportionally. Correct. As a result, what happens? Resistance at the output terminals vary proportional to the pressure applied. Okay. So next we will be discussing about pressure voltage transducer. This is the second type of uh, pressure transducers. Okay. So pressure voltage transducer, the name itself says here pressure is converted into its equivalent or its proportional voltage. Okay, in order to achieve this, we are making use of a potentiometer here. Okay, so if you go through the construction of the uh, pressure voltage transducer, here there is a bellow. Okay, here we have a bellow. So what this bellow will do? So it senses the pressure, and proportional to the pressure, it is going to move this slider. So this is connected to this slider. So it is going to move the slider according to the pressure it is going to sense. Okay, so this is the slider of the potentiometer. So this is the potentiometer. Correct. So So at these two terminals we can get the output voltage. Okay, so one terminal is connected to the slider, another terminal is connected to the another one of the terminals of a potentiometer. Okay, otherwise you can directly get the voltage value using this voltmeter only. Okay, so this is the battery, right? So what happens? So simple operation is there. Okay, so when pressure is applied, when pressure is applied, that is sensed by this bellow, and proportionately the bellow is going to move the slider. So when slider is moved, the output voltage across the terminals is going to change proportionately. So that can be recorded between these two terminals, or the voltmeter itself gives the value. Correct? So in this way, this pressure voltage transducer works. So voltage transducer uses a potentiometer. The potentiometer is used to convert pressure signal into an electrical voltage. So now we will discuss. So now we will be discussing inductance type pressure transducer. Okay. So figure 3 shows the inductance type pressure transducer. Okay. So here we have a non-conducting tube. Okay. So this one outer covering is a non-conducting tube. Okay. So inside that we have a movable core. So this one is a movable core. Okay. So this is a movable core. So this is a rod which will be connected to the Bowden tube. Okay. So Bowden tube is going to move this rod. So when rod is moved, this core present inside the non-conducting tube, okay, is going to move. Okay. So on the outer side we have wound the coil. So coils are wound. Okay. And to the coils we are giving the alternating supply. Okay. So basically it looks like a transformer. We have a coil. So inside the coil we have the core which is movable. Okay, which is movable, and its rod connected to the core is connected to the Bowden tube. Okay, so Bowden tube, whenever it senses the pressure, so it is going to move the core of the setup. Okay, so now we'll go through the points. When pressure varies, okay, the element causes the core to move. The element is nothing but Bowden tube. Bowden tube causes the core to move within the coil. Okay, an alternating current is passed through the coil. Okay, as the core moves proportional to the pressure, the inductance of the coil changes. What happens? So so when pressure changes, so when pressure is applied, so proportionately the core will move inside the coil. So as a result, what happens? Inductance of the coil will change. Okay. So later we'll see what happens. The current passing through the coil increases as the inductance decrease. So basically what is happening here is inductance is going to vary. So depending upon the variation in the pressure, inductance of the coil is going to vary, which will vary the current in the coil, current flowing in the coil. Simple. You consider, for example, inductance decreased. Okay. So if inductance decreases, what happens? Reactance is nothing but 2 pi FL. Reactance is given by 2 pi FL. So it will also decrease because L is decreased. So as a result, what happens? Impedance of the coil decreases. So when impedance of the coil decreases, what we will expect? Current flowing in the coil increase. Current flowing in the coil increases. Similarly, if inductance of the coil increase, it will also increase the inductive reactance. Hence, the impedance also increase. If impedance of the coil increase, current will reduce. So basically, what happens? Change in the pressure will be identified, is measured by change in the current. Okay, change in the pressure is converted into change in the current of the coil. So by measuring this change in the current, pressure value is measured. Okay, so this is how this inductance type pressure transducer is going to work. So summarizing the topics dealt today. So initially we defined some of the pressure terminologies like atmospheric pressure, gauge pressure, and another one is absolute pressure. Right. So later we have gone through construction and working of electrical pressure transducers such as resistive type. So in resistive type, we have gone through strain gauge type and moving contact type pressure transducers. Later we have gone through pressure voltage type uh, or which one? Potentiometric type transducer. And lastly, we have gone through inductance type of pressure transducer. Okay, so the possible questions which can be asked based on this discussion can be define. So question can be asked to define any of the three types of pressure transducers. So the question can be define the question can be like explain resistance type, potentiometric type, inductance type pressure transducers. Okay, and question can be asked to define atmospheric pressure, gauge pressure, and absolute pressure. So this question has been asked, okay, in the previous year's question paper. Okay, so a question was also asked on inductance type pressure transducers. Okay, so this is the reference textbook. Thank you.